am Professor Collins, and this is your daily dose of statistics. So today we're going to be talking about multivariate statistics, and particularly we're going to be talking about nominal and ordinal associations and interval ratio associations. And specifically, to be specific about this, what we're going to be talking about is the partial gamma and the partial correlation. This lecture will not go into multiple regression per se, but I'll touch on that briefly. We'll talk about some of the assumptions made for multiple regression, and particularly with partial correlation, and moving on into multiple regression based on the information we find. So we will be talking about several multivariate techniques. But first, let's do a brief introduction to multivariate associations. And so multivariate associations are, well, first let me take a step back. Bivariate explanations are usually incomplete. So when we're trying to predict some outcome, say grade point average, for example, there's usually a lot more things in that equation that create somebody's GPA, or that are predictive of somebody's GPA. So for example, somebody might spend X amount of hours in class, and that might be a little bit predictive of one's GPA, but there are probably other things that are just as predictive of GPA, if not more predictive of GPA. And so what we want to do is we want to gather additional information. So we want to look at things like intelligence, for example, and how that may fit into the equation, or fit into the explanation of GPA. And in addition, what this does, multivariate techniques, is we can bring these a variety of independent measures together, and there are different tests that we can both do statistically as well as theoretically to give some support to causation. It doesn't prove causation. Now remember, we can't really ever prove causation, but it provides more significant support toward causation. Now let's take a look at this idea of American exceptionalism, and I want to frame this with a little video. So let's show this little clip real quick.
Back in the book segment tonight, we continue with Charles Krauthammer in Washington this evening. New poll, Charles asked adults, do you often feel proud to be an American? 56% indicated they do. The rest, 44%, big number, say no, not often. About American exceptionalism, just 28% believe America stands above all the other countries in the world. 70% do not see it that way. So Charles, are you surprised by those numbers?
Well, no, not really. And the reason is that if you break it down by ideology or by party, it's mostly Democrats and liberals. For conservatives, the numbers are quite high on the patriotism, the pride, the exceptionalism. Those are traditional numbers. But these are Democrats and liberals who take their cues from the president. Remember, when the president was running in 2008, his wife, Michelle, said during the campaign, "This is the first time in my life," meaning with the reception Obama has gotten and his rise, "that I have been proud of my country." Can you imagine another first lady or president saying that? I can't. Now that wasn't just a slip. Then her husband ascends to office, becomes president. Then he travels the world and he conducts a tour. Forget about apology. It was a confession tour where he talked about all of America's sins on foreign soil, going all the way back to the maltreatment of the Indians, Hiroshima, ignoring the Europeans, dissing the Muslims, the list, including the coup that Eisenhower supposedly helped in Iran in 1953. That's going back a very long way. This is new. There aren't a lot of presidents who went abroad and confessed America's sins. We have our sins, but this is a president whose emphasis on it was quite remarkable. And then when he was asked on that tour about American exceptionalism, you remember his answer? Well, yes, I believe in that, as the Brits believe in British exceptionalism, the Greeks in Greek exceptionalism. Well, of course, if everybody's exceptional, then nobody is. So this is coming from the top, and this is the echo. that you are getting in Obama's constituency sort of reflecting his views.
All right, but what I don't understand is, with the president in so much trouble and all the polls reflect the job approval rating falling rapidly, okay, why his core still believe in him? I mean, or still echo what he says, because his point of view, his worldview is obviously not working, and it's making this country weaker. I mean, anybody could see that.
Well, they are a reflection of him, but in many ways he's a reflection of them. They elected him.
But they're shrinking that approval rating. There was a newspaper in Montana today said, you know, we were wrong to support him, and that's that crescendo is growing.
Look, a lot of the fall in his standing is because the hardcore of his own party, of his own ideology, got angry with him, particularly the young, over the NSA scandal. So it isn't that he is insufficiently conservative that's the problem. It's that he's insufficiently liberal for the hardcore left of his party.
Is that growing, that crew growing? It's always been pegged at 20% that are hardcore lefties.
So, in this video, it's not necessary to continue. So in this video, the two pundits talk about American exceptionalism, and they have various questions as to what is it that creates this exceptionalism? What is it that, what are some characteristics that would make people think America is more exceptional than other people? And Charles Krauthammer, the guy on the right, he indicated that it's liberals, right? So this idea that it's your political ideology that pushes you to be to rate America as exceptional or non-exceptional. So let's break down a couple of and so we're not going to get into the actual data of this. So we're going to use generated data, hypothetical data. So let's come up with some variables here based on this short little conversation about American exceptionalism. So on the nominal and ordinal scales, let's say we have a few variables, right? So we have, and we'll do y cat. And so in these cases, when you see y, that means it's going to be the outcome variable or the dependent variable. And so here our y variable is American exceptionalism, and it's rated on a scale of yes and no, right? Do you think America's exceptional, or do you not think America's exceptional? And then we have x, and so just like Charles Krauthammer said, maybe American exceptionalism, your ratings on American exceptionalism has to do with your political ideology, right? So maybe you're conservative, maybe you're liberal. And then maybe there's some other things in here that he didn't actually talk about. Maybe there's just one other variable. Maybe we hypothesize that if you traveled internationally, for example, that you may have different ideologies about American exceptionalism. And so this is what multivariate statistics does, is we're moving beyond the bivariate statistics, where we're just looking at a relationship between x and y. We're now bringing in a z variable. And let's also take a look at interval ratio variables. So we'll be using similar types of variables, and so just note that the nominal ordinal variables are on categorical scales, so they'll be identified by y cat, x cat, and z cat. For the interval ratio variables, let's say we measured American exceptionalism on a continuous scale, right? So this is an interval ratio type of scale of the way we measure American exceptionalism. So that'll be identified by y-con, as in continuous. X-con, or x-continuous, is, let's say, years of military service. Say we have a hypothesis that the greater time you've served in the military, the more exceptional you think America is. And then let's say there's this third variable, years of education, right? Say we're interested, say we think that years of education may play a role in American exceptionalism. And so we'll use these variables, and we'll look at different scenarios under which different outcomes can occur. And so we're going to take this big picture approach, and we're going to kind of zoom in to each thing individually. And so we have here is we have types of relationships, right? So when we're doing multivariate analysis, multivariate statistics, we're looking at the types of relationships between x and y, controlling for a third variable, or what we'll call z throughout this lecture. And just note, other statisticians call them something different, and there's slight changes depending on what you think you're measuring or what you're hypothesizing that you're measuring. So let's take a look real quick at direct relationships. And we'll start off by looking at direct relationships and conceptualizing those direct relationships. So let's take a peek into the conceptualization of what a direct relationship is. So in bivariate statistics, so we've gone over this, right? A direct relationship is simply the relationship between x and y. And in multivariate statistics, this bivariate relationship still holds even after z is introduced. And it's still only considered a bivariate relationship if z has no relationship to x or y, right? Z is just by itself, it's not related to either. So in this case, we really don't care about z because it doesn't matter. It doesn't tell us any of the story. And then we have direct multivariate relationships. That is where x is related to y, and then z is also related to y, right? So there's another relationship there. So there's another piece of the puzzle that we're gaining by introducing z into the equation. Now when we have a relationship like this, this is just a note, and we're not going to get into this. When we have a relationship like this is ripe for using multiple regression. And what multiple regression is if you remember going over regression, if not, take a quick little primer on it. Regression looks at the relationship of x and y, and it can predict y based on hypothesized numbers of x, right? Based on various levels of x. And so what multiple regression does is the same thing. It's the same basic equation with the addition of another variable, right? And so there are basic assumptions that we have to make in order to get to multiple regression, but just understand that that's what it is. It's you're adding a third variable into the equation. So you're looking at the extent to which y is predicted by x and z. And so let's understand direct effects real quick. So again, direct bivariate relationships mean that there's a relationship between x and y, and that relationship is consistent regardless of z. And z has really no effect on either y or x. Direct multivariate relationships, on the other hand, indicate that there's a relationship between x and y, and that relationship stays consistent regardless of z. However, z also has an effect on y, but not on x, right? So z has a direct effect on y as well as x has a direct effect on y. Now that's a multivariate relationship. All right, now let's take a look at using multivariate tables, specifically with nominal and ordinal variables, in order to be able to detect direct relationships. And so again, we're using nominal and ordinal variables in this case, and we'll be looking at detecting direct effects. And so remember, what we're doing here is looking at the relationship between x and y with or without z, right? And so let's plug in our hypothesized data here, our hypothetical data. And this is just a standard chart. And so to detect direct effects, we'll be using the chi-squared test. We can use the chi-squared analysis or the chi-squared statistics, but we'll be actually using what's called a gamma. And this is available in SPSS, and it also can be calculated by hand, which we will not go into in this lecture. And so what you want to look at here is we have our chart, right? So as you can see, conservatives and liberals tend to think that America seem to have about the same rate of American exceptionalism, and liberals tend to have more, tend to rate America as being not exceptional at a higher level, right? And so what we can do is we can plug in, or we can identify our gamma score. Now the way we're identifying the direct effect is to see if this changes when we introduce Z. Okay? And so let's say we introduce Z. Let's say we introduce international traveler, or international travel. So in this case, in this chart here, what you see is the political ideology related to American exceptionalism only for those who have traveled internationally. Now we can look at the non-international travelers, right? And what you can see is all three of these charts look basically the same. Then what we can do is we can grab the gammas and see if those have shifted. And so as you can see, the gamma in the right chart has shifted a little bit, but not a lot, right? It really has shifted not much at all. And the chart on the left for international travelers hasn't shifted at all. It's still the gamma at 0.4. And so what this tells us is that what we're doing here is we're detecting a direct relationship or a direct effect. And what we're identifying is that Z actually has no bearing on the relationship between X and Y. And so Z can either be thrown out, or we can add Z in as a potential multivariate predictor of Y. And so what is this telling us? So let's understand these direct effects. So again, the relationship between the X category and the Y category is consistent regardless of whether or not we introduce Z, right? So as you saw in those charts, after we introduced Z, the international travel variable, the relationship between X and Y, that gamma stayed the same. So what this is telling us is that international travel does not at all influence the relationship between political ideology and American exceptionalism. So we can potentially add international travel as an additional predictor of American exceptionalism, and we can conduct something like multi-regression, multivariate regression, for example, as an additional analysis here. Now let's take a look at detecting relationships, detecting direct relationships for interval, ratio, and also continuous ordinal variables. And so we'll use that with the Pearson's correlation. We'll use both the zero order correlation as well as the partial correlation. And so again, we're looking at the potential relationship between X and Y as well as Z and Y, the direct relationship. And so in order to do this, what we do is we run what's called a zero order correlation, which is simply a bivariate correlation. And so in this, what we can do is we can run a correlation between all three variables, X, Y, and Z. And the nice thing about this type of correlation matrix is that when you run it in something like SPSS, it gives you this output of all three variables. So it's not necessary to run each one separately. So what we're really wanting to do here is look at the correlation, the zero order correlation, between the X variable, years in the military, and the Y variable, American exceptionalism. And according to our hypothetical data here, what we find is that we have an R value, a Pearson's R value of 0.86. And so what this is telling us is that we actually have a fairly strong relationship between years in the military and ratings on American exceptionalism. Another thing to note as well, and this might give us an indication of a direct multivariate relationship, is that years in education has a negative relationship with American exceptionalism. So our Z variable has a weak relationship with our Y variable. And so this may explain some of the variance in our Y variable. And so what we want to do here, in order to make sure that we do have a direct effect, is we'll run what's called a partial correlation. And what a partial correlation does is it controls for that third variable. So it looks at the relationship between X and Y after controlling for, or after taking out the variance accounted for by the Z variable. And what we can do is we can compare those two numbers, those two correlations, and ask the question, are these two correlations, are these two Pearson R correlations so different from each other that Z is actually making an effect here? And so in this case, what we see is that we have a Pearson R, or a correlation of 0.8. And so what we're seeing is that the relationship between X and Y is still very strong. And it actually doesn't change much at all after introducing Z or after controlling for Z. So based on this information, what we can conclude is that there is a direct relationship between X and Y, and there may be a direct relationship between Z and Y as well, based on our weak negative relationship between those two variables in our zero-order correlation. And so now that we know this, what we can do, so this is the nice thing about this analysis, right? After we run our zero-order correlation matrix as well as our partial correlation matrix, if we identify this type of relationship, what we can do is we can move on to multiple regression. And we can use both Z and X as predictors of Y in multiple regression. And what that'll do when we move on to do that is it'll provide a stronger predictor of of the Y variable, right? So by adding additional variables in there that are related to the Y variable, what that does is it provides a more robust explanation of Y. So now moving on, let's look at spurious and intervening relationships. And so first what we'll do is we'll conceptualize those, and then we'll look at multivariate tables and how to detect those spurious and intervening relationships through nominal and ordinal variables, or for the ones that have nominal and ordinal variables. And then we'll look at them for ordinal continuous and interval ratio variables, and how to detect spurious effects with those types of variables. So first let's conceptualize what a spurious or intervening effect is. So the spurious relationship occurs when you have a Y variable, right? So again, this is your outcome variable, and you have your X variable, and you hypothesize that X and Y are related because maybe there's a correlation there. But what's in fact happening is that Z is causing both of them. So you have this third variable, this outside variable that maybe you didn't measure in the first place, or measure originally, that is actually the cause of both of these variables. An intervening relationship is, or this is often called a mediating relationship, happens when you have your X variable and your Y variable, but X causes Z and Z causes Y. So it looks like X and Y are related, especially if you don't measure Z, but what's in fact happening is the relationship between X and Y are occurring through Z. So this third variable, the Z variable, is sort of controlling the relationship between the two variables. Or in other words, it's mediating the relationship between these two variables. And so let's dig into this and understand it just a little bit, right? So in a spurious relationship, Z is the cause of both Y and X. And X does not have a direct relationship with Y. In intervening or mediating relationships, X causes Z, which causes Y. And X has either a partial or no direct relationship with Y. So X may have some influence on Y or no influence on Y, but at the end of the day, it goes through Z. And the way to detect this, and we'll look at this in a second, is that if the effect on Y is changed when Z is introduced, then we know that we have some spuriosity or some spurious relationships or some potential mediating relationships going on here. Unfortunately, and we'll talk about this in a second, the only way you can identify whether a relationship is spurious or intervening is theoretically. So you can't disentangle the two, right? Statistically, that is. You can only disentangle them theoretically. So let's take a look at spurious effects for nominal and ordinal, or categorical variables. And so again, y is not caused by x, but both y and x are caused by a third variable, right? Or x goes through z to get to y. And so let's take a look at our chart here. And so we have our y, American exceptionalism, plotted next to our x category. And again, we can see that about the same number of conservatives and liberals rate America as exceptional, but a lot more liberals rate America as not exceptional, right? And again, hypothetical data. And so we have our gamma here of 0.4. You can see kind of the theme there, right? So we have our same gamma score. Now what we want to do is introduce this third variable, and again we'll do international travelers, and just note again this is hypothetical data, so I can kind of tinker with this stuff, right? And what we can see is when looking at people who have traveled internationally, fewer conservatives tend to rate America as exceptional compared to not exceptional, right? So their trend line actually went down a little bit, as you can see. Liberals, on the other hand, their trend line stays about the same. Now let's look at a chart when we have people who have not traveled internationally. And what you can see is both liberals and conservatives in much fewer percentages rate America is not exceptional, right? So both fewer conservatives and liberals do not rate America as not exceptional. On the other hand, if they have not traveled internationally, more conservatives and more liberals rate America as exceptional, right? And so we can use this information and we can calculate a gamma. And so what you can see here is we have a gamma of 0.01 and a gamma of 0.01, right? So what this is telling us is before we had a gamma of 0.0 between American exceptionalism and political ideology, and that relationship has completely gone away after we introduce international traveling, right? And so that's how we detect spurious effects. And so what this is essentially telling us is that there's either a spurious or mediating / intervening relationship going on with this international traveling variable. So let's take a look at identifying these spurious and intervening effects. And so the way to identify this is that the bivariate gamma is plus or minus 0.1 compared to the multivariate gamma. Right? So after we introduce that z, we ask the question, is the multivariate gamma, after z is introduced, plus or less than, greater than or less than 0.10 compared to the bivariate relationship of x and y. Also, another way to identify this is if the multivariate tables identify no relationship between x and y, and the bivariate tables identify a relationship, right? So if that relationship goes away, again, after z is introduced, then we can sort of come to the conclusion that there's spuriosity going on. And unfortunately, as I mentioned earlier, there's no real way to distinguish between spuriousness and intervention statistically, only theoretically. So we'd have to dig into the literature or do further research to identify the difference between these. So let's just understand this real quick. So again, the relationship between x and y disappears when z is introduced if you have spuriosity or spuriousness. And what we come to the conclusion of is that z is somehow responsible for the relationship between x and y. So in this case, what we would come to the conclusion of is that international travel causes both political ideology and the perceptions of American exceptionalism. And there's no relationship necessarily between political ideology and American exceptionalism. So that's detecting spurious effects for categorical data, or nominal and ordinal data. Now let's take a look at detecting spurious effects with continuous data, or continuous ordinal data and interval ratio data. Now this is going to be very similar to looking at gamma, except what we're doing is we're again looking at that zero order correlation, right? So we'll pull up the zero order correlation matrix again, and we still have our correlation of 0.86, right, between our x variable and our y variable. And again, we still have our strong relationship, right? But to detect spuriousness, if spuriousness is occurring, what we'll see is after controlling for our z variable, the relationship between x and y really goes away, right? So it basically ceases to exist. And if this occurs, then you know that spuriousness is happening, right? And if spuriousness effects are occurring in this type of this type of relationship, you don't want to move forward and do something like multiple regression, because multiple regression can't handle. I mean, it can statistically handle this relationship, but you're going to get results that are really confusing. So what is this telling us? How do we identify spurious and intervening relationships, or variables with continuous data? And the first way to identify this is if the bivariate Pearson R, or correlation coefficient, is significantly stronger compared to the multivariate correlation coefficient. So is the zero order correlation table, is the relationship between x and y significantly stronger than after controlling for that z variable? And then if the multivariate tables identify no relationship between x and y, right, so after controlling for z, then that's another indicator of spuriousness. But again, there's no way to distinguish between spuriousness and intervening variables. There's just no way to do it statistically. We can do it theoretically. And so let's understand these effects. So the relationship between x and y, basically what it does is it disappears when z is introduced. And so what we can conclude is that z is actually responsible for the relationship between x and y in some way. So we might conclude something like our z variable causes, or our education z variable causes both the years of military experience and perceptions of American exceptionalism, right? And so we may conclude something like that based on the above analysis. And so that's detecting spurious effects with continuous data. Now let's finally move down to looking at interacting or moderating relationships. And so again, first we'll conceptualize. We'll look at the nominal and ordinal variables, or the what we'll call the categorical variables, and then we'll look at the continuous variables. So what is an interacting relationship? So an interacting relationship is when you have a relationship between x and y, but z influences the strength of that relationship, right? So you still have a relationship there, except z is manipulating the relationship. It's making it stronger for some people and weaker for others. And so what we can see here, in order to understand and detect this, the relationship between x and y changes when z is introduced. So it doesn't go away like in spuriousness, but it just changes, it shifts based on different parameters. Z may or may not have a direct relationship with y, but what z has a relationship is with the relationship between x and y, which is kind of confusing, right? But z can have an effect or an influence on the relationship between x and y. And so what we find when we have an interaction or a moderating effect is that z enhances the relationship between x and y for some people, and decreases or eliminates the relationship for other people based on that z variable, right? And so let's look at detecting these interacting effects or interaction effects with nominal and ordinal data, categorical data. Right, so these figures here at the top are basically the same thing. Right, so X leads to Z, Z1, which is a group of Z, and that leads to Y, and then so essentially what this is saying is that Z manipulates the relationship between X and Y. So again, let's take a look at our chart. We have our political ideology with American exceptionalism. We have our gamma of 0.40. And now let's take a look at what a moderating effect would look like. So let's take a look at international travelers. So when we look at international travelers, the conservative international travelers find America kind of equally to be exceptional and not exceptional. Liberals, on the other hand, if they've traveled internationally, tend to very much more find America to be not exceptional. And this is contrasted by non-international travelers, right? So you see these lines shift quite dramatically. And when these lines come together like this, we can say that there may be an interacting effect. And so what we see by the non-international travelers is that, especially for liberals, this completely shifts, right? This goes in the opposite direction, where liberals who do not travel internationally find America to be much more exceptional than liberals who have traveled internationally. And when we compute our gammas, right, this is very evident. So our gamma for the international travelers is 0.67, and our gamma for non-international travelers is negative 0.31. And so what we're seeing here is that this is completely international travel has kind of flipped the relationship between political ideology and American exceptionalism upside down, right? And so we can draw various conclusions from this. And so in order to identify the interacting variables, what we need to, what we're identifying here is that the bivariate gamma is plus or minus 0.1 compared to the multivariate. And each partial multivariate table is plus or minus 0.1 compared to the other partial Z table, right? Or the other partial multivariate table. So as you remember with spuriousness, the effects in both tables, both multivariate tables, just went away, right? They basically went down to 0. Whereas in this case, they didn't go down to 0, but one actually flipped signs. One became a negative. And so that's important to note. That's important to find out and identify. And indeed, if the multivariate tables change direction compared to the bivariate table, that's another indicator of potential interaction. So what does this all mean? So let's take a moment to understand the intervening, or what we also call moderating effects. And what we identify here is that the relationship between X and Y changes when Z is introduced. It's the same thing for spuriousness, right? The difference between moderation or intervention and spuriousness is that Z enhances the relationship between X and Y for one group and decreases or eliminates the relationship for another group. And so that's really important to identify and notice, right? And so what we can conclude here, based on our small little analysis, is that international travel causes perceptions of American exceptionalism to go down for liberals, but only has a little effect on conservatives, right? So what we're seeing here is that by introducing this Z variable, this international travel variable, it affects some people, but it doesn't affect other people, right? So in this case, it very much affected liberals, but didn't really affect conservatives a whole lot. And that sign shift was a big red flag too. If you see a sign shift like that going from positive to negative, then that's a pretty good indicator that you have intervention going on. So that's detecting interacting effects with nominal and ordinal variables, or categorical variables. Now let's take a look at detecting these effects with continuous variables. And we will actually not do that because that is beyond the scope of this lecture. Moderation with partial correlations can't really be done. It's very difficult to do. And multiple regression can do interaction, but it's a fairly complex thing to do. So there are other videos on it. I suggest you watch some of those. Read a book about it. There's definitely a lot of literature on moderation. So if you're interested in moderating effects for multiple regression, take a look at that. So we are going to stop here, and we're not going to go any further. So this lecture was intended to look at the different types of relationships after controlling for a third variable, right? And so we went over direct relationships, what those should look like for both continuous and categorical variables. We went over spuriousness and intervening relationships with both continuous and categorical variables and what those should look like and how to detect those. And then we also looked at moderation or interaction and what that relationship looks like after controlling for a third variable, a z variable, and how to detect that with nominal and ordinal variables. So that is the multivariate techniques. You were sort of at the top of the mountain here, so we're getting very close to before getting into some extremely complex statistical analyses. So this is about as far as you can go without getting into much more complex things like structural equation modeling, for example, or hierarchical linear modeling. Fortunately, those are all based on regression analysis. So if you have a good stronghold of regression analysis, you could probably get into those fairly easily. So that is our bit on multivariate statistics. And this is your daily dose of statistics.